Welcome to this lesson, and in this lesson we are going to be learning about classes and objects. In the previous lesson we did an introduction on object-oriented programming in Java, and in this lesson we would like to expound more on this. So the concept of object-oriented programming deals mostly with classes and objects. So in this lesson we want to see how we can be able to create classes and objects. Let's go to our project and define a new class. So to define a new class, you create a new file, for instance, a new Java class. And in our case, we are going to create a class called car.java. And as you remember, with the syntax of writing classes, the name of the class has to be the same as the name of the file. So for instance, our file name is car.java and our class is car. So we have public class car, that is the class definition. And to define a class as we said is a blueprint or a template for creating objects. So it normally has attributes. So classes have attributes, that's number one, and attributes and methods. So we are going to define some attributes of our car class and also some methods for our car class. Let's begin with the attributes. The attributes are normally the variables that are going to be used by our class or for defining the state or the data that our class is going to be interacting with. So we want to model a car, and our car is going to have a name. So let's have a name. It's obviously going to be a string data type, string name. It's also going to have an engine size. So let's have string engine size. Let's also have apart from a name and engine size, let's also have what else does a car have? We can have color, string color. And also let's have another data point or another attribute called weight. So these are the attributes that we have for our class car. We have the name, the engine size, the color, and the weight. We can go ahead and define some methods. So let's define some methods for our class. As we said, classes are normally going to have two major things: attributes and methods. Attributes to represent the state of an object and methods to represent the behavior of an object. For instance, by state we mean an object can be of state. For instance, its name. What is the name of that car? It could be an Audi, it could be a Mercedes, and so on and so forth. Its behavior: it can drive, it can brake, it can check the speedometer, and so on and so forth. That is the behavior or methods. Let's define a method called drive. So we are going to have public void drive. Of course, by now I know you already are very well familiar with the syntax for writing methods. So let's define a method for getting our car to drive. So what do we want to say? We want to say, for instance, the name of the car, and then to say that it is driving. So for instance, if the name of our car is Audi, we want to say that Audi car is driving. So let's have the name, of course, the concatenation operator, then car is driving. A bit of a typo there, it's driving. So this is how simple our method is going to be. The name of the car is driving. Let's have another method called brake. Public void brake. Let's get our car to brake. So the name of the car is braking. Very good. So up to this point, what we have is a class that contains attributes and methods. So that's a fully qualified class. We have defined the attributes of that class and the methods for that class. And what we have defined is that our car, any car or any object of the type car that we create, can have the attributes or the state of the name, the engine size, the color, and the weight. And it can also have the behavior of the methods for drive and brake. So let's find out how we then create objects from this template or from this blueprint. So let's create our main method from where we are going to instantiate our objects and learn how we can be able to create these objects. So you remember, of course, the syntax for writing the main method: public static void main. The main method, as we said when we were starting the series, is that it's the main entry point to the Java program. So in this main method, we are going to define an object, and how you define an object is through the syntax that you are going to see right now. You write the name of the class, in which case the name of our class is car, then followed by the name of the object that you want to create. In our case, let's say car1, then followed by the assignment operator and the new keyword. The new keyword is used to create new objects from a class. So followed by new car. Of course, you remember the parentheses. So in this way, we have created an object of the type car called car1. So right now we have an object of the type car called car1. How do we set attributes? So this is object creation. How do we set attributes to our car? We can say car1 and use the .accessor operator, which is able to access the attributes and the methods of the class. So we can say car1.name equals to, in this case, let's have Audi. Car2, let's set all the attributes. car1.engine size equals to, sorry, I think I pressed the wrong key. 3000. car1.color, service red, and car1.weight, serve a random value here. Yeah. So we have defined an object and we have set it attributes. So let's get to drive or brake, and we simply car1.drive. So that's how we access the method as well, and there is also car1.brake. Very good. So we have created one object. Let's create another object and find out how this works. So we can create another object that is going to take advantage of the blueprint that we have created for the car class. So we can say car, the name of the car, followed by the name of the object that you want to create. Let's say car2 equals to new car. Then car2.name the Mercedes-Benz car2. So the object name dot property, car2 dot engine size equals to, let's say that 500. Then we have car2 dot color. Let's have it as wine red, and car2 dot weight. It's another random value. Very good. So we have defined two objects. So we have defined the second object, which is car2, and we have set its attributes. So let's also call its methods car2.drive and car2.brake. So what we have done here is that we have created objects, two objects. Car1 is one object and car2 is another object, and we have set their attributes and called their methods. So let's see how this works. So let's run our program and find out what the output would be. Very good. So we do have an output. So for the first object, which is the Audi, we have Audi car is driving and Audi car is braking. For the second object, we have Mercedes-Benz car is driving and Mercedes-Benz car is braking. So what do you learn from this? What you learn from this is that we only wrote the code for driving or braking only once. We only wrote this code only once, but we have been able to use it for the Audi car and for the Mercedes-Benz car. We only define the attributes, the name, the engine size, the color, and the weight only once in the car class, but we have been able to use them on both the objects of the Audi and the Mercedes. This enhances the concept of the don't repeat yourself principle, programming principle, and making use or avoiding repetition and having reuse of your code, which is